Okay, so if I said to solve this problem, what would you think the first step would be? If you were looking at this problem, you wanted to solve this, I would cross multiply, right? So let's go ahead and cross multiply. Could we technically multiply by the least common denominator? Yes. I think that would be silly though for this problem because it's just two fractions. So let's go ahead and cross multiply here. Okay, and then I think you guys can solve this. So I'm gonna let you guys finish this problem out. Check your answer with your neighbor. All right, so we should have gotten x equals -5 for our answer. Okay, there's technically one thing that I actually forgot to do. What is that? Restrictions, right? What can x not equal?
-3,
-1 and -3. Okay? So I don't need to omit any answers in this problem because it's -5. However, we do need to check our restrictions, okay? Especially because this next problem is talking about an inequality. Remember last class we did one example like this. We had to create a number line, figure out which intervals made that inequality true or false, and that was what was our answer, okay? It was an interval of numbers. So for letter B, we don't actually need to do any solving because we already have our 3 kind of critical points there that we need to test. Okay, so I'm just going to go ahead and draw myself a number line here. And on my number line, I'm going to put those 3 values. Any restrictions, and then also the answer that I got, which was -5. So I'm going to plug -5, -3, and -1 on my number line here. How many points am I going to need to test in order to test all of my intervals? 4, right? There is to the left of -5, to the right of -1, and then in between those 2 in the middle. Okay, so I've got 4 intervals that I need to test, so I need to pick 4 different points. So when you're doing this problem on your quiz or on your test, okay, I need to at least at the bare minimum see what point you are plugging in. Okay, so like if I plug in 0 on the right, I need to see that you wrote 0 here or you wrote test 0 something because I need to make sure that you plugged in something. If you don't show this next step, that's okay. But the more work you show, the more chance there is of you guys getting partial credit, right? So I'm going to go ahead and plug in 0. When I plug in 0, is this inequality true? That is what we are asking ourselves. So I plugged in 0 back into my inequality. 4 less than 2/3, true or false? False, okay? False, X, F, whatever you want to do to label it. Everything to the right of -1 makes that inequality false, okay? Now, at the points -1 and -3, since I can't have them be equal to, what kind of circle am I going to have on those 2 points? Open circle on both of those, okay? Which really, these are like our vertical asymptotes here, right? What sets the denominator equal to 0? What makes that equal to 0? So -3 and -1, it can never cross. What about -5? What do we think about -5? Is it going to be an open or a closed circle? Any ideas?
Closed.
You think closed? Why closed?
Because if you plug it in, they will both equal each other.
But do I have an equal sign here underneath that? No, so I think you just talked yourself through that one, I think. So it would actually be an open circle. And that's exactly right. If there was a line underneath this, okay, and I solved this equation and I got -5, then I would have a closed circle. But since there is not a line underneath it, it would be an open circle at that point, okay?
Wait, so why is -1?
Because those are part of our restrictions that we can't have it equal. Those are technically those vertical asymptotes. Good question. All right, now we gotta pick a point in between -3 and -1. What do we want to pick? -2. So I'm plugging in -2. Okay. We see if this inequality is true, we'll say true, and that part is our interval that makes our inequality true. So I would simplify this. I would get -2 less than -2. Wait. No, I did that wrong. I really did that wrong. -4, right,
Yes.
is less than
Tell you whether or not.
-2. That's the correct math there, right?
Yes.
Positive 2.
Yeah.
No. Yeah.
-2.
Because it's
It's
-2
positive
plus
2.
positive
Oh,
two.
it is. It's +2.
I got you guys. Yes. Thank you. plus 1. There we go. Or plus 2, sorry. Okay, 2 is in fact greater than -4, so this is a true interval. Check mark there. In between -3 and -1 is going to be part of my solution. So we've got to test 2 more points. Okay, I'm going to test a point to the left of -3. So maybe like, I don't know, -4. And when I plug in -4, let's see if I can do my math right this time. I got 4 over -3. Is that less than 2 over -1 or -2? So is -1.3 repeating less than -2?
No.
Nope, false. So that interval is not true. Then we got one more number to check. Number less than -5. It doesn't matter what the number is. What do you want to check? -6. If I plug in -6, and I simplify those fractions, I get -4/5 and -2/3. So is -4/5 less than -2/3? Yes, it is. If you don't believe me, you could plug this in your calculator as a decimal. It'd be -0.8 and -0.67. You will get a calculator on your tests when you're plugging in these numbers and stuff. If you need it, use it. Okay? So when I'm writing my answer for this inequality, I need to write it in terms of interval notation. So that means from the farthest left point to the farthest right point in that interval. So this interval is true and this interval is true. So I need to write that as my answer from -infinity to -5, but I'm not including -5 because I don't have a closed circle. And then I am also including -3 to -1. Okay, so anything in between those two intervals, if I plug it into this inequality, it will make the inequality true. Okay? Questions on this one? Yeah. Do you mean, what do you mean? So like the one on the homework, let's just kind of talk through that one. If it was like you had this, but instead of less than, it was greater than. Okay? You're going to do the exact same thing. You're testing all the same values. However, if we were looking above as which ones are less than, and now I want to know which ones are greater than, aren't these intervals just going to flip?
Oh, so
right?
You have 2 different number lines.
Yes, 2 different number lines, and then 2 different values for when they're true and false, and then that you would give me those 2 different intervals. Okay? Well, let's go ahead to the next page. We're going to do a word problem here, and then we'll have time to work on our homework. Okay? So we're not doing example 7, so you can cross that out. We're only going to do example 6 there. You will need your calculators for this one. So let's go ahead and read example 6. Vehicles arrive randomly at a parking garage at an average rate of 2.6 per minute. The parking attendant can admit 3.2 vehicles per minute. However, since arrivals are random, lines form at various times. So letter A says that the traffic intensity, X, is defined as the ratio of the average arrival rate to the average admittance rate. Okay, so that was average arrival rate, was given to us as 2.6. And the admittance rate was 3.2. Okay? So our X, which is our traffic intensity ratio, traffic intensity, I can't talk and write at the same time. That is our variable, and that is what it stands for. We are going to write this as a ratio, or a fraction of 2.6 over 3.2. Okay, it's the average arrival rate over the admittance rate. So if we plug that in our calculator, 3.6 divided by 3.2 on our calculator should give us 0.8125. Okay? So that is our traffic intensity value, okay? Letter B is now asking us. It says the average number of vehicles waiting in line is modeled by this function, f of x equals x squared divided by 2 times 1 minus x, where x has to be in between the points of 0 and 1, okay? It says to compute f of x for this parking garage. So let's make a little note here. What does this f of x function stand for? Like, what is the output that I'm getting in if I put in the x of the traffic intensity number? What am I getting out? Yeah, it says the average number of cars, right? Average number of cars waiting in line is that f of x. Okay, if I put in the traffic intensity, whatever that variable is, okay, I will get the output of the average number of vehicles waiting in line. Okay, so it's saying to compute f of x for this parking garage of the given intensity that we just found in letter A. So what are we going to do? What are we going to do? Plug it in, right? I'm going to plug it in. So I'm going to plug in this 0.8125 for x. Okay, so go ahead, quick in your calculator. I don't know why I wrote it that small, but in your calculator, go ahead and plug that in for me and see what you get. Okay, so this one you said you got 1.76? Or was that what it was? Yeah, 1.76. Okay, perfect. So, again, what does this mean in terms of our problem? 1.76. We plugged in that traffic intensity of the 8125, which means our output is the average number of vehicles waiting in line. So there's an average of 1.76 vehicles waiting in line, okay? Letter C, it says to graph the function using a calculator. So I want you guys to plug in this function that is highlighted in yellow on your calculator. Do not plug in the 0.8125, but plug it in with the x's on your y equals and graph it. And then look at, as the x values approach 1, what is happening to your y values. Okay? So plug this in your calculator real quick. If you got questions, I'll be around to help. So after we have graphed it, you guys should have something that looks like this. Doesn't it like go up like that? And then I don't remember what the other side actually looks like. Does it just go down? Oh yeah, it's like a weird little thing like that.
Yeah.
Okay? So as it approaches 1, as our x values approach 1, what is happening to my y values?
They're going up.
They're going down. They're going up, right? All right. So as the traffic intensity is approaching 1, the average number of cars is increasing rapidly. All right, and the last one here that we need to interpret and solve for is if we know that the function of x is equal to 24, we need to figure out what does that mean and when I solve for x and what does our answer equal. So I've got this function up here. I'm going to set it equal to 24 and I'm going to solve. Okay, so I've got 24 is equal to that function that was up in yellow of x squared over 2 times 1 minus x. Okay, this is something that we should be able to solve. I would probably start solving this by cross multiplying. Okay, so if I cross multiply, I've got 24 times 2 times 1 minus x is equal to x squared. Now, just be careful with when you are cross multiplying here. Make sure you are multiplying 24 by the entire quantity of 2 times x minus 1 minus x, whatever it is. Okay, make sure you're multiplying everything by that. So the way that I wrote it kind of shows that you need to multiply that entire thing. So I'm going to go ahead and do those in parentheses first. And now if I start solving this, what are we going to end up having to do? If I've got an x squared, we're either going to have to factor or we're going to have to do the quadratic formula. Okay? So if I solve this here, I get 48 minus 48x is equal to x squared. But in order to factor or do the quadratic formula, it has to be equal to 0, right? So I've got x squared plus 48x minus 48 is equal to 0. Now, last class I had quite a few people struggle with plugging this into the calculator using the quadratic formula. So quick reminder, you guys remember the quadratic formula? Hopefully. I'll write it here. How many of you guys learned it to the Pop Goes the Weasel song? A lot of us. What else did we listen to? The Soldier Boy one, divided by 2a. It's a good one. Look it up. Okay. So I had people plugging this in the calculator like this. What's wrong with that? It has an x. I don't actually plug the x into the calculator, right? The a, b, and c of your quadratic formula is just the value that is in front of where the a value is, the b value is, the c value. So your a value is just 1. Your b value is just 48. And your c value is negative 48. Now the other thing that people are struggling with is negatives versus subtraction signs on the calculator. If you plug it in with the wrong one, it's going to say something like domain error, okay? So you are using a negative symbol in front of your b, and if you are plugging in your c here, right, as a negative 48, when I plug it in, I'm going to use the negative button, okay, which is just down right next to your enter sign. I'm going to use the subtraction sign when it is in between b squared and 4ac, okay? So what I want you guys to do right now is try plugging these things into the quadratic formula. I'm going to give you what you should be getting, okay? These are the answers that you should get, but make sure that you are able to actually get these answers on the calculator, because this is something that you might have to do on a quiz or a test or on a homework assignment, and I want to make sure you guys can do it on your own, okay? So plug these into the calculator real quick, and if you guys need any help, please let me know. All right, so between these two answers that we finally got with our calculators, 0.98 and negative 49, which one is not accurate? Which one can we not have in terms of this problem?
Negative 49.
The negative 49, right? It doesn't make sense in terms of our problem. So the 0.98, what this is actually saying is when the traffic intensity is approximately 0.98, okay? There are 24 cars on average in line. Okay, now you're not going to be quizzed over this on the quiz on Monday, but you will have something like this where you have to interpret some X's and Y's and what they mean on your test. So you'll see them again before we get to that point. We'll get some more practice on it, but it makes the most sense to put it in this section, so that's why we're doing it right now. Okay, any questions on this?